Hello, welcome back to Cracking the Cryptic, where I'm going to continue in our theme of sort of combining standard Sudoku with maths by taking a look at this puzzle, which has been requested by one of our viewers. And I think that they are saying in the email that they have solved this puzzle, and it involved quite an innovative logical technique to do with an L-shaped box, whatever that might mean. So you can see this is another of these puzzles from dailykillersudoku.com. It's a little bit different from the one that we showed earlier in the week. It's still 10 out of 10 rated in difficulty, but this one has greater than and less than and equal signs appearing between some boxes. So we'll have a look at how they work in a minute. You can see the average solving time is nearly an hour, which means this is an extremely difficult puzzle. So let's load it up and take a look at how we might solve it. I'll get it, just position it in the box, and off we go. Now, so hopefully it's pretty obvious what these inequality signs means. This means this box has a greater total than this box. It doesn't refer to the square, so it's not saying this square is bigger than this square. It's saying this whole box is bigger than this whole box. So where would I start? Well, as usual, I'd start with the givens. A 3 box in 2 cells can only be 1 and 2. A 17 cage in 2 cells can only be 8 and 9. And is there anything else? Ah, yes. Let's have a look at this 3 cage here. You can see it's greater than this cage, which is a 23 cage. So for a 3 cell cage, the maximum we can get to is 24 if the numbers are 7, 8 and 9. So that is forced. This must be a 7, 8 and 9 in this box. Something interesting we can do at the top here. This 7 cage is greater than this cage, so the maximum value of the highlighted cage therefore is 6. But look, this shares a 3x3 box with a 9 cage. So we know that these 5 cells together must be a maximum of 15, which is helpful actually, because the only way to get to 15 in 5 cells is with the numbers 1, 2, 3, 4 and 5. They add up to 15, so there's absolutely no way that these 2 cells could be less than 6, because then we couldn't actually get to the required number using different digits. We'd have to have a repeated digit, which is obviously illegal. So these 2 add up to 6, so they don't contain a 3, therefore there is a 3 in this 9 box. But this cell of the 7 cage is now forced, because it can't be a 1, 2, 3, 4 or a 5, so it must be a 6. Well, that's a 1. The 5 cage must now be a 2 and a 3. And these 3 cells must be 7, 8 and 9. And this cell here, the highlighted cell, can't contain 6. So this can't be a 7, which means that this is a 4 or 5. And there is a 7 in one of these 2 positions. Right. So we're doing okay. Let's just highlight the options for the open positions in this 3x3 block. We're looking at 4, 5, 6 and 7, where we know these 2 cells are greater than these 2 cells. Okay. But look, we can do something with the 1s. There's a 1 here and a 1 in one of these 2 positions. So in this bottom 3x3 block, there cannot be any 1s in these cells. Therefore, there is a 1 in the 16 cage. And maybe that's helpful. Let's have a look at the 23 cage. What are the options here? So, no, I'm not seeing how to do anything with that. Let's have a look at this. This might be the L-shaped box that the person was referring to. It's a fairly big number, 27, going round this corner. It can't contain a 1 for the reasons we looked at earlier, so let's get rid of all the 1 options. Okay. Right, this is interesting, this box, because we have an 8 and a 9 in one of these two positions, and we have a 7, 8 and 9 over on this side. And when we looked at this 27 cage, look at the options. There is always an 8 or a 9 in all of these options. So let's just consider for a moment, is it possible, because we know the 8 and the 9 can't be in these positions, so the 8 or the 9, or both, must be in these two positions. But look, this is extremely unusual. Let's just imagine for a moment that this was an 8-9 pair. What would the effect of that be? Well, because of the impact on this square, these two cells here would have to be an 8-9 pair. Now, that means that we'd have an 8-9 pair here, an 8-9 pair here, and given the 8-9 pair here, in this bottom 3x3 block, what numbers could be 8 and 9? Only these two squares. But if there was an 8 and a 9 in this 16 cage, we'd already have broken it. So that's really lovely. So this cannot be an 8-9 pair. So we can eliminate this option, and we know that one of these squares is an 8 or a 9, but not both. So, and we can do a similar type trick here. Let me show you what I mean. Let's imagine this was a 9. Whatever we choose for, let's say, if this is a 9, this square won't be a 9, and therefore there will be a 9 in one of these two positions, and that will interact again with the 9 here. And because this is a 9, that will force a 9 into one of those two positions. So whatever the number is over in here, whether it's an 8 or a 9, and we know it must be one of the two, that number is forced into this 16 cage. Okay. So, and it's forced into one of these two squares of the 16 cage. So let's just think about that for a moment. If one of these squares was a 9, what would that mean? We can do another trick. Look, I will show you what I mean. So, let's have a look at this square. We know that either this square or this square is an 8 or a 9. But look, we already have a 30 cage in this block here. So, if this was a 9, 9 plus 30 is 39. Now we know that the whole of a row in any Sudoku puzzle will contain obviously the numbers from 1 to 9. So it will add to 45. If you add the numbers from 1 to 9, you get 45. So if this is a 9, these three cells have got to sum to 6. Well, that's just not possible, because we can never get a big enough number into this 13 cage. 6 can only be made with 1, 2, and 3. So that doesn't work. So this is not a 9. If this is an 8, these three cells have to be equal to 7. They'd have to be 1, 2, and 4. And you can see we already have a 1 and a 2 in this 3x3 block over here. So there's no way of filling these two squares in that situation. So this square is not an 8 or a 9. Therefore, the 8 and the 9 must be in this position. This cell here is an 8 or a 9. And that puts quite a lot of restriction on the remaining part of this 16 cage. Obviously, if it's a 9, the remaining cells would have to add up to 7. They would have to be 1, 2, and 4. If this was an 8, then these three cells would have to sum up to 8, so they'd need to include a 1, as we know, so it's either going to be 2 and 5, or 1, 3, and 4. So we can add those two like that. So, how can we restrict those options further? Well, one way is if we look at the options for the 23 cage here, that's over on this part of the grid, you can see every option that doesn't contain a 1 does contain the numbers 2 and 3. These bottom 3 here, they all contain the numbers 2 and 3. Well, there's already a 2 and a 3 here. So actually, these 3 options are not possible because then we couldn't fill this cell. And therefore, this 23 cage does contain a 1. Now, we know that the 16 cage also contains a 1 from the work we did before. So the 1 would have to be in one of those 2 positions. So there is a 1 in one of these 2 positions, and there is not a 1 here. Now we can use the 45 trick again though on this column. Let's just double check what the options are, because we've got 23 here. So if this is a 9, that would give us 32. We would need these 3 cells here to add up to 13. So if this is a 2, these 2 would have to add up to 11. Well, that's not possible. 3, these 2 cells would have to add up to 10 without using another 3. That's not possible either. So this, I don't think this can be a 2 or a 3. Obviously, if this is 8, we need to make even bigger numbers, so that's just not going to work. So this cell is not a 2 or a 3. This is a 4 or a 5. And therefore, we can't have a repeat 4 and 5 because we know these 3 cells are either adding to 8 or they're adding to 7. So this is a 1, 2, 3. There's a 1, 2, 3 pair or triple now in column 1. So this must be a 4, 5, or 6. We can't have 7 in either of these 2 squares either. So right. So I think that's as far as we can take that logic. We've used this column. So let's have another look at this row. So now we've got 30 in these positions. So we know these 4 cells have got to add up to the difference between 45 and 30. Well, that's 15. But these 2 cells are a little bit restricted because we already have a 1 and a 2 in the cage. So the minimum here would be a 3 and a 4, and a 3 and a 4 would have to be this way round. These 2 would then add up to 7, which means these 2 would have to add up to 8 without using a 4 or a 3. Well, that's not possible. If we could make this a 5, but that would force this to be a 3. So 3 and 4 doesn't work. Let's check 3 and 5. 3 and 5, these 2 have to add to 7. No, that doesn't work. Whatever we choose in the 4, 5 square breaks. Let's try 6, 3, 9. These have to add up to 6 now. That is possible. Okay, so 6 works. 7, these would have to add up to 5. They'd have to be 4 and 1. Yeah, that works. Okay. 8 doesn't work because these 2 would have to add up to 4. They have to be 3 and 1, which would repeat a 3 and is impossible anyway. So, and then obviously anything bigger than that. So the only option so far we've discovered that works is with the 3 in this square. Let's just increase this then and see if that's going to work. Now if this, hang on, let's just fill in the options here. We have a 1 and a 2 here, so this square is part of a 6 cage. That can only be a 4 and a 5 therefore. So as I increase the value of this, I get restrictions in terms of what I can put in this square. So if this is a 4, for example, I can't make this square a 5 because this square will already have been a 5. So the minimum value then is 4 and 6 in this square, which is 10. These 2 would have to add up to 5 without using a 4. That's not possible. So this cannot be a 4. 4 and 7 obviously isn't possible because then these 2 have to add up to 4 again. That's not going to work. So 4 does not work. I'm presuming 5 doesn't work either. 5, then this is a 4, this is a 6. Yes, that doesn't work. Okay, so this is a 3. This 13 cage therefore is 6 and 7. This is not a 3. This is an 8. This is a 9 after all that work, which means these 3 have to add up to 7, which means they are 4, 1 and 2 in that order. which means this is a 3, and there's a 2 there. 1, 2, 4, 9. We can fill in this square because we know we've got 23 here. Plus 2 plus 4 plus 9 is 38. This must be a 7. This is a 4, 5, 6. We know there's an 8 or a 9 in one of these positions, but we don't know which one yet. We have a 1, 2 pair here. These 3 cells we can work out the value of, because we can use the 45 rule again. Let me show you what I mean. If we highlight these cells that I've highlighted, you can see that the cages that I've highlighted here are entirely contained within rows 8 and 9, and they add up to 76. So given we've got 2 lots of 45, as will be the total for both of these rows, 2 lots of 45 is 90, so these unmarked cells must add to 14, and we have to get to 14 without using a 1 and a 2. So I think the options are going to be 3, 5 and 6 and 3, 4 and 7. Either way round, there's definitely a 3 obviously in this cage. And in this cage here, the 30 cage now does not have a 3 or a 4 in it, so let's get rid of all those options. So you can see it must contain an 8 and a 9, which we know must be this side of the line. It must also contain a 5. This can be a 5 as well, actually. And it's either, the other 2 digits are either going to be 1 and 7 or 2 and 6, and I can't resolve that yet. So, okay, but look here. In this 3 by 3 block, this cell can only be 4, 5 or 9. So it can't be a 9. This is a 4 or a 5, which means this is a 9. That's useful, hopefully. 9, 9. Yes, that is useful. It's more useful than I was expecting. It's useful in a few ways. Firstly, this has to be a 4 or a 5. 4, 5. Now we know that the digit that's appearing in one of these 2 squares is a 9. It can't be an 8 anymore because the 8s are locked into one of those 3 positions. Just to remind you, the reason we know that is we know that the 2 options here that are valid for the 30 cage both include an 8, and we know the 8 cannot go here because there's already an 8 in column 3. So the 8 must be there, so it cannot be in either of these 2 positions. So this 27 cage does contain a 9 and doesn't contain an 8. So we can eliminate it a little bit further. We might be able to go further than that even. Don't know. Yes, we can go further than that. Look, there's a 2 here. So this 23 cage doesn't contain a 2. And therefore, where can I put a 2 in this box? Well, it can't be down here. It can't be down here. It can't be here because this is part of a 12 cage in 2 cells. So there is a 2 in one of those 2 positions. So it's not that one. Okay, so we're now closing in on the value of this 27 cage. This, I think, is the sort of L-shaped, interesting cell that had that logic at the beginning. So what is the next number we get to put in? Let's just take a look along the top column here. 4, 5, 7, 8, 9. Yeah, this cell is restricted, and there's a 7 here, in fact. So this is a 7. 4, 5, 8, and 9 into these 2 positions. And in column 9, we already have a 4, 5, and an 8. So this is a 9. Therefore, this is an 8. This must be a 5. 8 and 5 here. And this is a 4. 9. Now this 8 means that this is a 9. So now the 9 must be here. Okay, because we've eliminated it from here because of this 9. This one is not an 8, so the 8 is in one of these 2 positions. Okay, I feel like I should be able to make a bit more progress now. Sorry, there might be some children's noises in the background. Let's just go back to this 23 cage again. We know it contains a 1. And we know it doesn't contain a 2. And it doesn't contain a 7. There's a 7 here. That's the one I've missed. So it's either of these two options. And it doesn't contain a 9. There we go. 1, 3, 5, 6, and 8. So this square here can't be a 4. That's nice, because this square can't be a 4 because of the inequality sign. If this is a 4, these two cells sum to 11, and these two cells, because there wouldn't be a 4 in them, would also sum to 11. This is not a 4. And the other thing you note when you go through these difficult daily killer Sudoku puzzles is they tend to have a very logical solving path, very linear. So, you know, this inequality sign suddenly comes in at exactly the right moment to help us disambiguate, all of which is intended, I think, by the algorithm they use for testing the puzzles. Okay, so now we know this is a 5 or a 6, so we're looking for 3, 5, 6, and 8 into these cells here. This one here, can we restrict at all? Not obviously. Okay. This 5 resolves that 5 down there. There's no 2 into these positions. So there's a 2 here. That resolves this 1 and the 2 over on this side. So there is now no 2 in this 30 cage. That resolves the 30 cage. This is now 1, 5, 7, 8, and 9. So this square here can only be a 5 or a 7. There must be a 1 and an 8 into these positions. So does this help with anything? This now must be 3, 5, and 6. Which means that this is a 6 and this is a 7. 6, 7, 4, 9, 1, 2. Okay. So what are the options then for the 27 cage that are left? 2. We know it contains a 2. We know that 2 must be here. And a 9, obviously. So if we're looking at this option here, this would be 4, 5, and 7 into these two positions. 4, 5, 7. 4, 5, 7. Is that possible? And oh, hang on, we've got 4 here. That means this must resolve itself like that. This can't be a 5 anymore. So 5 is locked into one of these two positions in this 3 by 3 block. Therefore, there cannot be a 5 in this 27 cage anywhere. It's actually really beautiful the way that this shape interacts throughout the puzzle. This is almost sort of an empty rectangle situation. The fact that there can't be a 5 in any of these 4 squares has a really profound implication once you lock a 5 into this position, and similarly with the 8 up here. Once this is an 8, you force an 8 that way. So, all of which means this is 3, 6, and 7 to complete this block. So, 3, 6, 7, 3, 6, 7, like that. Now, does that in and of itself help us? 7 here, so I can eliminate the 7 from those two positions. this is 9 here, so we can eliminate that. 9 in one of these two positions. 6, 8. Oops, I need to do that. So now we have 3, 5 and 6 as a triple in this cage down here. So this cannot be a 5 in there, which means this is a 5. Which means I can eliminate the 5 from this square. 5, 6. So this square is now very restricted, isn't it? We still have to put a 4 in this box. We haven't managed to do that yet. That must be a 4. That's a 6. And that means there's no 4 in here. And now the 9 cage is forced, look. Because we can't put a 4 here in the 9 cage, because then these two cells would have to sum up to 5. And with the options we've got remaining, we can't do that. So this is not a 4 either, which means the 4 is in the cage we said was equal to 6 at the start. So this is not a 1 or a 5. So there's a 2, 4 pair here and a 4 here. So that resolves itself. 2, 2, 2 in one of those 3 positions. This isn't a 2 here. And I still need to put a 4 in this 3 by 3 block, look. That can only go here now, so let's put the 4 and the 8 in. This can't be an 8. And we've got, that can't be a 6 either. So 1, 3, 5 and 7 to these two positions. 3, 5 and 7, but we don't know anything about this cage in terms of its sum, so I don't think that's going to be terribly helpful. 6 here. 6 in either of these two positions. I don't see a way of resolving that. 1, 2. This 9 resolves that position. I don't know if that's going to help very much. 8, 8. There's an 8 in one of those two squares. Again, this is part of a cage that we can't know the value of, so I don't think that's going to be a way of breaking into this. This can't be an 8 anymore. 6s, 4s. Blah! It's getting quite difficult. It's already been quite difficult. Well, one thing we could do is to have a look at this cage here. It's a little bit complicated, isn't it? Because we have this 3 cage and this 2 cage equal to one another, with this other 2 cage greater than whatever they happen to be. So I think the first thing we need to do is to highlight the values that we've got left to place. We've got 1, 2, 6 and 7. This can't be a 7. This can't be a 2. This one can be anything. This one can be anything, I think. 5, 5, 5, 5. Oh, hang on, 8s. We've got an 8 here. That can't be an 8. So this is a 1, 7 pair, and this is an 8. So 1, 3, 5, so there's a 9 in... this 23 cage is more limited than I thought it was, because we've already got a 6 and an 8 in the block. So we can't have a 6 and an 8 in the 23 cage, which means we can eliminate loads of these options. So we're left with options that must include a 9 and a 7. We know the 9 is in one of these positions, but the 7 must also be in those positions. There you go. So that resolves like that. That gives us a 3, 5 here. Eliminate a 1 from that side. This can't contain 7 anymore. 1. And we know in these two positions we've either got 2 and 5 or 3 and 4, but we need to put a 4 in this block. Look, we have a 4 here and a 4 here. So that must resolve in that order. Aha! Now we are starting to get somewhere. Good. So we can eliminate 6s from these two squares. 3 and the 5 fixes itself. This can't contain 3, so it does contain a 1 and a 5. And that means this must be a 2. Let's tidy up the remaining numbers as much as we can. 3, 7 pair there, so this square here must be a 2 as well. 2s. Three, 7, 5, 6. Wow. So we've got some more numbers there, but I don't think it's cracked this yet. I think we are going to still have to have a look over here. Eliminate the 2 from that position. Right, so let's think about this. The minimum value of 3 cells in any killer Sudoku is 6, if they're in the same 3x3 block, that is. So if this is 6 and this is 6, that adds up to 12. Plus 4 is 16, so that's not enough. These two cells here would have to add up to 29. Now the maximum value for 3 cells is 24, so 6 isn't going to work, 7 isn't going to work, 8 probably isn't going to work either, because that will make these 3 have to add to 25. So we're already making a little bit of progress. Is it possible this is 9? So 9 and 9 would be 18. Plus 4 is 22. These 3 cells here would have to add up to 23. So this would have to be a 6. This would have to be 8 and 9 into these positions. That doesn't work, because if this is a 6, this has to be a 7, and this has to be a 1. But we know these two add up to 9, so this would lead to a repeated 8. There'd be an 8 here and an 8 in one of these two squares. So 9 isn't possible. Is 10 possible? 10, 20, 24. These 3 have to add to 21. So 1 and 2 wouldn't work. Is 6 possible? We should probably just confirm whether this is possible or not. So if this is a 6, that would be a 7. This would be 6 or 7. This would have to be 9. These two would have to be 7 and 8. And is there anything wrong with that? 9, 9, 9, 1, 2, 6, 7, 8, 3, 3. So this would be 5, 3, 2, like that, which looks okay. Except, of course, we've got 5 and 6 here, which clashes with this cell, so that doesn't work either. Let's unwind that. So, what does that mean? Did we... 7, 6... Well, if this was 7 on the other hand, could that work? These have to add to 21. I suppose we should just check it. 7 here would make these add to 14, so they'd have to be 5 and 9. No, that doesn't work because we already have a 5 and a 9 in this column. So 10 doesn't work. 11, that would give us 22. Plus 4 is 26. These would have to add up to 19. This couldn't be a 1. This couldn't be a 1 in that instance, though. Let's just have a look at that. We said these two are adding up to 11, so this would have to be a 6 and a 5, like that. 6, 5, 11, 2, 8, 9 would work. This would be how it would look. Okay. can't see why this doesn't work, but I just want to, so rather than go to the nth degree, I just want to prove to myself that that no other numbers work. So we've worked out that 11 might work. Could 12 work? 12 might not work for another reason, because if we put 12 into both of these squares, that's 24, plus 4 is 28, but we know these two would have to be at least 13, which is 41. So we'd have to in fact make this bigger than 13 in order to reduce this to a 1 or a 2. So this would have to be 15, I think. I'm doing this mental arithmetic in my head. 15 or 16. Is either of those a problem? Probably both of them are a problem, I think. Let me show you why. Once this have to add up to 12, this would have to be a 5. This would have to be 6 or 7. 5. 5, 5, 5, 5, 5. There's a 5 up here as well. 6 is. This would be 6. This would be 7. So now how can we make this equal to 15 or 16? We can't, because either option is not going to work. If this is, we can't put 7 or 8 or 6 and 9 into this square to make 15, and we can't put 16 in with 7 and a 9 here either. Goodness me, that is complicated. Okay, so that does not work. I think that was a 2 over there, which allowed us to eliminate a 2. So 12 doesn't work. 13, 26, 44, this would have to be a 1. I'm pretty sure that's not going to work, but let us just prove it to ourselves. 1, 1, 6, 7. This would have to be a 2 down up here. 13. So this has to be 14, and it can't be 6 and 8, and it can't be 5 and 9. So no, that just doesn't work. Right, all of which is an incredibly difficult way of explaining that in fact the only option for this cage therefore was when it was 11 and when this was a 6. So that is forced, which means we can unwind 6 and 7 here. Now what do we know? We know 11, 22, 26. So we're looking at 19, so this is 2, this is 8 and 9, which must be in this order. And this has got to be 1, 3, 7, which makes this a 3, this a 7 and this a 1. That resolves the 9 and the 7 here, look. This has got to be a 5, 6 pair. And probably now we're on the home stretch. I don't want to speak too soon, but I'd be surprised if there's anything more complicated to find now, especially as the numbers are starting to go in a little bit more swiftly. Okay, so what do we need into these two positions? We need numbers 8 and 9. So, in fact, let's just clear them. Put 8 and 9 in like that. 1, 3, 8. So these two can't be 8 anymore. This one can't be a 5. 5, 8, 9. I feel like I should be able to resolve this somehow. What am I missing? Oh, there's no 9 in here, that's what I'm missing. So this is a 9, this is an 8, this therefore is a 3. 3 here, 3 and 7, oops, like that. Okay, this will have to be resolved by something that's going on over on this side, I think. So let's try and complete the columns now. We've got 2 and 6 into these two positions. This will have to be the 8. Therefore this should be a 3, which means that resolves itself, which means that resolves itself. And there we go. 1 second puzzle. Far from it. 40 minutes. That is absolutely brutal, but you won't see too many puzzles out there that are harder in terms of the interaction of sort of Kukuru logic, geometry, and basic Sudoku technique. So for those of you into extreme puzzles, there you go. If you enjoy the channel, please do subscribe. We appreciate that. Give us a thumbs up. We also live in the belief that the YouTube algorithm somehow recognises that, but we don't really understand how. And thanks very much for watching. Back soon with another edition. Cracking the Cryptic.